Hello students, today I am going to solve one NEET based question, previous year question. That's why I have selected this question in the thermodynamics. If you have learned about this concept, definitely you are having 4 marks with your hand. So this is an important concept, that's why I'm dealing that one. You can check the previous year question, whatever may be the question. If you are checking, definitely this concept will be there, that about this according to this concept there will be at least one question. So 4 marks you are having with your hand. So this is actually the Hess law concept. I will explain about that one. First of all, what are the given data? Bond energies of HH. Actually, according to NTA part, bond energy is nothing but the energy given to break the 1 mole of bond. Actually, 1 mole of single bond molecule you have to take, and if you are breaking, and you should be very careful. You have to take that in gaseous state. So when you are taking 1 mole of molecule with a single bond in gaseous state, and if you are breaking that molecule, then you can consider that heat energy given for the breaking as bond enthalpy or bond energy. You please recall that again and again, that is recall that again and again. You please pause this video and again refer my definition. So you should be very careful. The stoichiometric equation, which is about that bond enthalpy. That is the stoichiometric equation, which is indicating that bond enthalpy will be like this: H2 gaseous state you should take, and you have to break that H2 into 2 hydrogen atom. So we can say this one as atomization enthalpy as well as bond enthalpy. I will explain one more thing, but this is not related to the question here. Look at this. When you are considering this carbon dioxide, 1 molecule of carbon dioxide gaseous state, and if you are converting that into 2 oxygen and 1 carbon, it can be called as atomization enthalpy, but this is not bond enthalpy. So you should be clear on that bond enthalpy and atomization enthalpy. Bond enthalpy is nothing but the energy required to break the molecule into constituent atoms, and the molecule should be with one bond, and the molecule should be with one bond, and the molecule you should take with 1 mole, and it should be in the gaseous state. So then only you can consider that enthalpy change as a bond enthalpy. So they have given the bond enthalpy of a hydrogen. I have represented the stoichiometric equation for that bond enthalpy of hydrogen. That is actually 430 according to the given data. And then the second case, Cl2. When you are taking that Cl2 in gaseous state, again, if you are converting that Cl2 into 2 moles of chlorine atoms, then the bond enthalpy here will be 240 kilojoule per mole. And then look at this one more thing. So if here chlorine is also having 1 mole, right? One bond. 1 mole of chlorine is having 1 mole of bond. Single bond is there. That's why you can consider that as a bond enthalpy, as well as HCl. When you are breaking the HCl into gas, then you will get to the H and Cl. So here also we can consider this one as a bond enthalpy. Let me check that one, whether they have given the HCl bond enthalpy. No, they have given the formation enthalpy. So here we don't know. They didn't give that one. So they are asking that bond enthalpy of this one. So for this stoichiometric equation, they are asking the enthalpy change. The enthalpy change for this reaction will be called as bond enthalpy of HCl. Remember that. Why I am telling the definition again and again, why I am telling the theoretical part again and again, because that is very important. When you are dealing with the other question, you have to know what is formation enthalpy, what is bond enthalpy, what is atomization enthalpy, like that. So look at this, and here they have given the formation enthalpy of HCl. So always the formation enthalpy defined as the enthalpy change of 1 molecule formation. Only 1 molecule should be formed. That is 1 mole of molecule should be formed. Whatever may be the state, gaseous, solid or liquid, whatever may be. 1 molecule should be formed from the elemental state of that molecule. So H and Cl will be the constituent atoms, but it is not in the elemental state. So look at this. Actually the definition is enthalpy change involved in the formation of 1 mole of molecule from the constituent atom's elemental state. So the constituent atom's elemental state will be H2 and Cl2. Look at this, the elemental state of hydrogen will be H2 in our room temperature. The elemental state of chlorine will be not, actually they are not in a monatomic state. They will be in diatomic state. But the elemental state of helium will be monatomic state. Elemental state of oxygen will be diatomic state. Elemental state of nitrogen will be N2. And then elemental state of phosphorus will be P4, like that. So you have to consider only the elemental state, that is in our room temperature how it exists, that is called elemental state. So hydrogen cannot be there in the monatomic state, it can be exist only with the diatomic state. So H2Cl2 and HCl, they have given the bond enthalpy for this one, formation enthalpy they have given, right? The enthalpy change for this reaction can be considered as a formation enthalpy, 90 kilojoule per mole. You please look at the unit. Actually, they have given the same unit here. Sometimes they will play with the unit. Be careful about that. Okay. But here the same unit is there, so not necessary to bother about that one. I will solve that question. They are asking the bond breaking enthalpy, that is bond enthalpy of HCl. I'm going to use Hess law. First of all, the elemental state H2 and Cl2. Okay, 1 minute, 1 minute. I didn't solve this one because we have to get only 1 mole, right? But if you are balancing that one, you will get 2 mole. Then you will not get that could not be considered as a formation enthalpy. If you 1 mole formed, then you can consider that as a formation enthalpy. That's why you should take 1/2, 1/2. So half moles of H2. It's not half molecule of H2. Half moles of H2. Half moles of H2, half moles of Cl2 will produce 1 mole of HCl. So half mole of H2, half mole of Cl2 will produce 1 mole of HCl. It will produce that is the energy released in this one will be 90 kilojoule per mole. This is the direct process. According to Hess law, when you are directly converting A to D and indirectly converting, that is you are following so many steps, A to B, B to C, C to D, then the delta H for this reaction will be equal to delta H1, delta H2, delta H3. This is actually the Hess law. So heat energy will be the additive property, delta H1, delta H2, some exceptions are also there, but you will not, don't worry about that one, because in 11th standard you can follow the Hess law. But for further future studies after 12th, you can learn that one. That is a Hess law's exception will be there. But here no more exceptions. So you can add the delta H with the direct process, and the indirect process delta H will be the additive property, delta H1, delta H2, delta H3. So I'm going to take the indirect process now. So look at this, how I can take the indirect process. First of all, why I'm taking that indirect process? Because I don't have that data, right? I don't, so by using that indirect process only, I will get the bond enthalpy. So look at this. First of all, I'm going to break that H2 gas into H. So, but here I'm not breaking that 1 mole of molecule. I'm just breaking a half mole of molecule. So half into bond enthalpy of hydrogen. So bond enthalpy of hydrogen will be 430. And then bond enthalpy of chlorine, again half into 240, because I have taken only half mole of chlorine in gaseous state. So here it will produce HCl, and overall it will produce HCl. So H and Cl will give HCl. This is not formation. Formation will be considered as a, here sometimes students may write the minus 90 here. This is wrong. 90 is there for the formation enthalpy from the elemental state, but HCl is not at all actually the elemental state. Look at this. Actually, they need the bond enthalpy. That is the reverse reaction they are asking. HCl to H and Cl. Look at this. HCl to H and Cl they are asking. But we have to find out that forward by using Hess law. Then we can convert that sign. That is, we can give the opposite sign for this one. Then we will get to the bond enthalpy. Let us solve this one. So according to Hess law, minus 90 will be equal to half into 430. So 2, 1, 5. So 215. Bond enthalpy will be always breaking enthalpy. For breaking, we have to give energy. So it is always endothermic. And then here it will be 120. So 120. Wait a moment. 120 And then finally, here we are converting H and Cl, monatomic state, and we are converting HCl. That we don't know. So I'm just taking that as X. So here 315 and the 335 it will be, right? 335 plus X will be minus 90. So X is minus 90 plus 330. Sorry, actually when we are taking that minus in plus into left hand side, then it will be minus 335. So X will be minus 425. Actually, it is minus 425 because it's formation, right? But we need the breaking enthalpy. That is why 425 will be the final answer. So let me check whether this answer is given in the chart. Yes, 425 is there, right? Actually, this is very, very basic. But you can expect that one in previous year question. Nowadays, they are asking somewhat difficult question. So you have to solve this basics. That is, first you have to solve this basic concept of Hess law. Then you can solve that type of question. If you are having any doubt, you please post me. Thank you. Thank you, students.